Hello, my favorite number is 42. It's the answer to the question about life, universe and everything. And also in Lewis Carroll's Alice in Wonderland it plays a major role. Kester, what do you think?
I think that's too small.
Too small? I think I've got an idea. Recently I was reading about father primes. I try this.
What are father primes? Father primes of order n is 2n plus 1 multiplied with a prime number p plus 2n. For example, with n equals 6, we have to multiply the prime number with 13 and add 12. For the first one is 38, which is not a prime number, so we rule this one out. Take the next one, the 3, and we get 51. It's also not prime, it's ruled out. For the 5 we get 77, not prime, ruled out. But if we multiply the 7 with 13, add 12, we get 103, which is a prime number. And that's the first father prime of order 6. We can continue with the 11, it's 155, that's not prime. But with the 13, we get again a prime number, 181. And this is the second father prime of order 6. We can continue forever. And since my favorite number is 42, I have looked for the 42nd father prime of order 6, which is 8501. Isn't that a very nice number?
Kester, what do you think? 8501, isn't that a nice prime number?
It's a nice prime number, indeed, but it's still too small.
Still too small? What can I do? I think I have another idea. 8, I take 8 times the 3. 1, 2, 3, 4, 5, 6, 7, 8. I take 5 times the 2. 1, 2, 3, 4, 5. And I take 1, 0. Now I've got 14 digits and I can compose a very nice number, very big number. 3, 2, 2, 0, 3, 2, 3, 3, more threes, plenty of threes, 2, 3, 2, 3, 3, and another 2. So how does this look like? I don't like this. A 2 at the end cannot be a prime number. I put a 3 at the end. Let's read this. It's 22 trillion, 32 billion, 333 million, 232,333. A nice number. Kester, can you check if it's a prime number?
Okay, I'll ask Wolfram Alpha. Well, that was fast. And indeed, it is a prime number.
My MegaFAF number has also practical applications in life, universe and everywhere. For instance, if you want to fly to Mercury, which is the subject of my YouTube channel.
Let's look at planets in our solar system. Johannes Kepler in 1619 discovered a basic law. The square of the orbital period t of a planet is direct proportional to the cube of the semi-major axis a of its orbit. So t squared equals 4 times pi squared a to the power 3 divided by mu. And mu is the gravitational constant of the Sun, which is a product of the universal gravitational constant multiplied by the mass of the Sun. This formula we can now also apply at Mercury. But for Mercury, the gravitational constant mu now is 22 trillion, my mega favorite number. And this we will now apply to calculate the orbital period of a spacecraft that has already orbited Mercury. And this is a Messenger, which is the only spacecraft so far which has gone around Mercury. It was launched in August 2004 and arrived in March 2011. And also we can apply the same formula for Baby Colombo, a ESA-JAXA mission, which was launched in October 2018 and is now on its way to Mercury and will arrive in December 2025. Well, I have prepared a small Python script to calculate the orbital period of these two spacecraft. I've entered here the gravitational constant of Mercury, the 22 trillion, my mega favorite number. First I have to enter the perihelion, which is the closest distance to Mercury's surface, which was for messenger 200 kilometers or 200,000 meters. The apoherm, the first distance away to Mercury's surface, is 15 million meters. And now the next step is I calculate the semi-major axis, which is just the average between perihelion and apoherm, added to the Mercury radius. And now I apply my formula, orbital period, which gives the value in seconds. So I have to divide by 3600 to get it in hours. I add a print statement. If I run it, the orbital period is 12 hours. If you wonder why it's exactly 12 hours, well, the US spacecraft controllers, they wanted to have fixed days and night shifts and want to have their lunch always at the same time. If we now calculate the orbital period of Baby Colombo, the Mercury planetary orbiter of Baby Colombo, the perihelion is 480 kilometers, the apoherm is 1500 kilometers, which gives an orbital period of 2.36 hours.
So my megaFAF number is really useful. And now I have a conjecture which I invite you to check. This number is the 42nd largest number which was submitted to the challenge of megaFAF numbers, because 42 is really my favorite number.